Okay, so let's wait for everyone. Let's just wait for everyone to join just quickly. Yep. So, hello friends, those who are watching this live session, a warm welcome to each and everyone. Those who are watching this, we'll just wait for few people to join this live, and then we can just start with our today's topic. Yeah, you can just type it in the chat box. You can just say hi. Yep. Yeah. Okay. So I'll just share this slide actually, which this is our today's topic. We will be learning about what's atoms and molecules, and we will be studying about hi, hello. So Kushagar, yup, hello, hi. So today we will learn about the numerics. The numerics of this chapter, atoms and molecules, will just go through in detail actually whichever type of numerical is there in this chapter, and we'll try to cover each and everything within the stipulated amount of time. Okay. So before that, hi Dinesh, hi, hello, welcome to Letstute. Hello everyone, welcome to Letstute. Let me just start with it. Okay, so welcome to Let's Dude, guys. If you haven't subscribed to us, then you can subscribe to us. There will be a small subscribe button, and also beside that, it will be there will be a small bell icon which you can press so that you never miss an update from us. And also something about our website. We have a website known as www.letstudent.com. So you'll find amazing courses over there related to math as well as science, and we have a lot of courses across many platforms. So just check the description box so that you be updated with our courses. Okay. And today's topic is atoms and molecules. We'll just revise whatever we have learned in the previous live sessions and just go through the numerics of this chapter. And just let me just remind you guys, this chapter is very important, and the numericals are also very important, and it has mole concept. So this mole concept is very helpful in your future studies also. Kids get confused that what is this mole concept, how do we get mass out of it. So actually it is very simple. So those who are watching this live, connected, just stay tuned so that we can just cover this whole numericals. Okay. So we'll just wait for a few minutes for more people to join, then we can just start. So let me just quickly explain you what we will be learning in this live session. So we will be learning about various numericals, actually numericals related to how to find number of atoms, what will be the mass, what is molecular mass, what is the mole concept, how to find number of moles, what is Avogadro's number. We have discussed what is Avogadro's number, and what is actually the value of Avogadro's number. So these are certain topics which will be we will be covering today. Okay, so let's start without wasting any time. Okay, so let me just share it. Okay, so our first question, is, in a reaction, 5.3 grams of sodium carbonate reacts with 6 gram of ethanoic acid. So there's an equation given over here, and along with that, certain mass is given to us. Okay, okay, good explaining. So okay, so so there are certain values given to us which will be we will be using. So these are the certain values, and it's stated to us that show that these observations are in agreement with law of conservation of mass. Now, what is law of conservation of mass? We should understand that. So law of conservation of mass is that the mass before the reaction and after the reaction is exactly equal. So this is the law of conservation of mass, that mass is neither created nor destroyed in a chemical reaction. Okay, so let us try to put in the values of sodium carbonate, ethanoic acid, sodium ethanoate, and carbon dioxide and water. These are the values which are given to us. We just substitute them and try to find out whether the statement is true or not, whether the law of conservation of mass is being applied or not, whether it's satisfying the condition or not. So if we try to add both the sides, 5.3 plus 6, that will give us 11.3. And in this side also, if we try to add all the values, that is 8.2 plus 2.2, that will give us around 10.4. And if we add 10.4 with 0 0.9 grams, it will give us 11.3. So as you can see, the value on the left hand side is exactly equal to the value on the right hand side. So this holds the law of conservation of mass. So this was about law of conservation of mass. So it is satisfying the condition that the value or the product, the mass of the product and the mass of the reactant is exactly equal. Let us try to jump on the next question. What is the next question? So next question is about conservation of constant proportion. Actually, it's about constant proportion, law of constant proportion. So let us try to answer this question. So it's given hydrogen and oxygen combines in the ratio of 1:8 by mass to form water. Okay, so we know that by their mass they combine in the ratio of 1:8. So in this condition, they have given mass of oxygen, mass of hydrogen. Actually, they have given that what will be the mass of oxygen gas that would be required to react completely with 3 grams of hydrogen gas. So how much amount of oxygen will be required to completely react with 3 grams of hydrogen. This word completely is very, very important. Please keep it in your mind. So we will deal with how it reacts incompletely, and the values are not reacted, or the elements are not reacted at all. But in this condition, it's reacting completely. So we know the ratio is 1:8. They have given us mass of hydrogen. So in place of hydrogen, we'll just replace it by 3. So if we try to arrange all the factors and we try to bring oxygen on the upper side or the numerator side and arrange everything together, what will be the equation which we get is oxygen is equals to 8 into 3. So if we try to solve this, if we try to solve this equation, we will get this equation where it says oxygen is equals to 8 into 3. So if we multiply 8 into 3, that will simply give us 24 grams. So this equation states that, or this value states that we will completely react with 3 grams of hydrogen gas. I hope this thing is very, very clear to you guys. Okay. So this was about how hydrogen reacts completely with oxygen and what will be the mass. So using the law of constant proportion, we found out this value of oxygen. Okay. So in the next example, what they have given us that when 3.3 grams of carbon dioxide is burned in 8 grams of oxygen, they have given that 3 grams of carbon dioxide is used and it's burned in 8 grams of oxygen. So it's produced, the amount produced, the carbon dioxide produced is 11 grams. So this is the value of the carbon dioxide. Now, if they have given what mass of carbon dioxide will be formed when 3 grams of carbon is burned in 50 grams of oxygen, they have simply stated what will be the amount of carbon dioxide produced. What will be the amount of carbon dioxide produced if 3 grams of carbon reacts with 50 grams of oxygen? In the first statement, it was given that 3 grams of carbon dioxide reacts with 8 grams of oxygen to form 11 grams of carbon dioxide. So this is the equation which we get. And the ratio between their masses is 3:8. We know that carbon reacts with oxygen in the ratio of 3:8. But now in this condition, they have introduced 50 grams of oxygen. So what will be the reaction? So the reaction will be very, very simple. We just add 3 grams of uh, carbon dioxide with 50 grams of oxygen. We will get 11 grams of carbon dioxide. Please understand this properly. We will get 11 grams of carbon dioxide and remaining 48 grams of oxygen will be unreacted. It won't combine with carbon. Why it won't combine? Because they have to maintain, they have to follow the law of constant proportion, and in constant proportion 3 grams of carbon can only react with 8 grams of oxygen. It cannot react with more than 8 grams of oxygen. So in this condition only 8 grams of oxygen is being used. Okay, so I'm so sorry, this will come actually 42. This will be 42. Okay, so this will be 42. It's not 48, it's 42. 42 grams. Okay, so this was about the amount which remains is 42 grams of oxygen. I hope this thing is very clear. So what they have asked, which law of chemical combination will govern your answer? So the law of constant proportion, the chemical combination ka law of constant proportion will govern this equation. Why? Because only 3 grams of oxygen can react with 8 grams of oxygen. Okay, so I hope this was clear. Next is, how can we calculate molar mass or molecular mass of a particular molecule? We have learned this in our previous live sessions. Actually, how can we calculate molecular mass? And molecular mass is nothing but it's just addition of all the atoms. It's just addition of all the atoms of the atoms in the molecule. We just have to add all the atomic masses of the atoms in the molecule. Okay, so we know what is atomic mass of hydrogen, we know what is atomic mass of nitrogen, we know what is atomic mass of oxygen. Now the formula is exactly like the number of atoms they are using. So in first condition, hydrogen is using one atom, so we'll just multiply 1 by the atomic mass of hydrogen. In the second thing, nitrogen has, we have only one atom of nitrogen, so we multiply 1 by the atomic mass of nitrogen. In the third thing, we have 3 atoms of oxygen, so we simply multiply atomic mass of oxygen by 3. So atomic mass of oxygen is 16, we just simply multiply it by 3. We just calculate everything together and our answer gets to 63U. Now what is 63U? 63U is nothing but it is the mass of the molecule. It is the mass of the molecule. It's the molecular mass of the particular molecule. So this is the way you're supposed to find out the molecular mass. You just simply add all the atomic mass. Okay, so I'll just explain you guys once again, but before that, let me just say you can just check it on the comment sections. Also you can just find our website links, that is www.letstute.com. You can just find some amazing videos over there. You can find videos related to math as well as science, and the videos are actually very nice. And you can also subscribe to our channel, and don't forget to press the bell icon so that you are updated with all our live sessions. So let's continue with the calculations actually. So this was about calculating molar mass of this particular molecular mass of this particular molecule. So next is, how can we calculate molecular mass of this particular molecule? So it's very, very simple actually. The formula which we used over here is exactly same for this formula also. We just simply have to write down all the atomic masses of the atoms. So atomic mass of calcium is 40 and chlorine is 35.5 U. U means simply unified mass. So we calculate atomic masses and unified masses. So number of atoms exactly. So chlorine has 2 number of atoms, so we just multiply it by 2. And calcium has only 1 atom, so we just multiply it by 1. So 40 multiplied by 1 and 35.5 multiplied by 2. We just simply add both of them together and we get our molecular mass. So molecular mass of this particular molecule is 111U. That is 111U. Okay, so I'll just explain once again for you guys. It's so in this particular thing, what are we supposed to calculate? In this thing, we are just supposed to calculate what is molecular mass. Okay, so I'll just explain you what is the step of calculating molecular mass. So simply, we just have to add all the atomic masses of the atoms present in the molecule. So in this molecule, we have calcium, we have chlorine, we have two atoms of chlorine, and we have one atom of calcium. Okay, and we are supposed to add the atomic masses of them. So what is the atomic mass of calcium? Now, what is atomic mass? Atomic mass simply means what is the mass of a particular atom. So mass of calcium is 40U and mass of chlorine is 35U. We just simply have to multiply it by the number of atoms. So in this particular case, chlorine has two number of atoms and calcium has one number of atoms. So we just simply multiply it and add it. I hope this doubt is clear to you. Yeah, so I hope your doubt is cleared. Okay, so let's move to next example. This was all about molecular mass. Now let us try to understand some different concepts. Okay, so in this also we are supposed to calculate what is the molecular mass of all these molecules. So in this I have highlighted all the molecules which we have to find the molecular mass of these particular molecules. So let us try to understand how can we find out. Okay, so let us take the first molecule. The first molecule is ZNO. Okay, I'll just change the color actually. Wait a minute. Okay, so I hope this is clear. So ZNO. So in this case, we have value of Zn. Value of Zn is 65. So 65U, and the number of atoms. The number of atoms is nothing but 1. So I just simply multiply 35U by 1 plus. Now what is the value of oxygen? What is the value of atomic mass of oxygen? It is 16U. So I'll just simply add 16U over here, and we have only one number of atom, atom. So I'll just multiply it by 1. So 16 multiplied by 1, that gives us 16, and 65 multiplied by 1, that will give us 65. Now we simply have to add both of them together. We just simply have to add 65 plus 16. So we will get the value as 81. So now remember, you also have to write down the unit. Always remember, the unit of molecular mass is nothing but U itself. U means unified mass. So this is the first answer. This is the value for ZNO. Okay, I hope this one is clear actually. Let me just clear this whole thing. Now let us try to solve the next molecule. Okay, so the next molecule is Na2O. So what is Na? Na is 23, and we have two atoms of Na. So I just simply multiplied 2 by Na ka atomic mass. What is atomic mass of Na? Na ka atomic mass is 23U. Okay, I added by oxygen ka atomic mass, and we have only one atom of oxygen. So 1 multiplied by atomic mass of oxygen. So atomic mass of oxygen is 16U. Now we just simply multiply all of them and try to add all of them. So 16 multiplied by 1 gives us 16, and 23 multiplied by 2 will give us 6, and 2 2s are 4. So it will give us 46. Now we just simply add both of them. So 6 plus 6 gives us 2, and carry 1. 6 plus 6 is 12 actually. Carry 1. 1 plus 1 is 2, and 4. That gives us 6. So this is our final answer. So this is 62. But please don't forget to write down the units. Okay, so please don't forget to write down the unit. The unit is same as atomic mass. It's unified mass. It's U. Okay, so this was about Na2O. Now I'll just require answers from the comment section. Actually, can you just find out the third molecular mass for me? Of course, I'll help you guys, but just try to find out what will be the mass of K2CO3. Try to find out what can be the molecular mass of K2CO3. Okay, So please write it down in the comment section. By the time even I'll help you to solve it. Okay. So what is the value of K2? We have K ka value as a potassium ka value as 39. So 39, this value, we just simply multiply it by 2 because we have two atoms. We have two atoms. Adding that value by carbon. So C, what is the value of C? C is nothing but 12. So we just add it by 12 plus what is the value of O? Oxygen ka value is 16, but we have 3 atoms of oxygen. So we just multiply it by 3. Okay, so 39 multiplied by 2 plus 12 plus 3 multiplied by 16. We just add all of them together and try to answer it. So can anyone answer me in the chat box? So we just multiply 39 by 2. That will give us 78 actually. So let's try to answer it over here. 78. Adding it by 12 plus 48. Okay, so these are the values which we get. We get it as 78 plus 12 plus 48. So we just add all of them together, and what is the answer we get? We get it as 138. And don't forget to mention the units. Okay, so it's 138 U. I hope you got this answer. Okay, yeah. So let's try to move further thoda sa. Okay, so what is moles? Actually, this concept is very important. Please listen to this very carefully. Okay, so in this question is given 4 moles of aluminium atoms. So 4 moles of aluminium atoms, and what are we supposed to find out? We are supposed to find out what is the mass. What is the mass of these 4 moles of aluminium? Okay, so the simple formula is we just multiply it by number of moles multiplied by the atomic mass. So whatever is the atomic mass of the particular element, we just multiply it by number of moles. So in this condition, we have 4 as number of moles. And what is the atomic mass? The atomic mass of aluminium is given to us. It's given as 27. So it's nothing but 27 U. So atomic mass of aluminium is 27 U. And the number of moles is 4. We just simply multiply both of them and we get our mass. Our mass in grams. Please remember the mass will always be in grams. Okay, so this is mass in grams, and this is the mass of 4 moles of aluminium atoms. So this was how you were supposed to use mass. This was how you were supposed to use number of moles and atomic mass. Okay, let's try to solve few questions more. Okay, so in this example, they have given us 0.2 moles of oxygen atoms. They have given us 0.2 moles of oxygen atoms. And what are we supposed to find? We are supposed to find the mass. Okay, so what is the mass of these atoms? 0.2 moles of oxygen atom. What is the mass? The formula remains exactly same. The formula is mass is equals to number of moles multiplied by the atomic mass. Okay, so the number of moles over here is 0.2. The number of moles over here is 0.2, and we just simply multiply it by the atomic mass. The atomic mass of oxygen is nothing but 16. The atomic mass of oxygen is nothing but 16. So we just simply multiply 0.2 multiplied by 16, and that will give us 3.2 grams. So this is the final value for 0.2 moles of oxygen. So values, the mass of 0.2 moles of oxygen is 3.2 grams. Okay, so I hope this concept is very clear to you guys. Let us try to solve few more sums. So this is a very important sum. In this, what they have asked us, they have asked that if we have these many number of nitrogen atoms, if we have these many number of nitrogen atoms, what will be the number of moles actually? So number of moles formula is nothing but the number of atoms which they have given us, the number of atom which they have given us divided by the Avogadro's number. Now what is Avogadro's number? Avogadro's number is nothing but 6.022 into 10 raised to 23. So this particular value is our Avogadro's number, and we simply divide it by the number of moles which is given to us. Okay, We just simply divide both the values together, and what we get is 0.5. So this is number of moles. Okay, so this is number of moles. Now if you want to find out what is the mass, if you want to find out what is the mass of this particular number of moles or number of moles of nitrogen, so you just simply multiply number of moles with atomic mass of the particular element. So now the atomic mass of nitrogen is 14. So we just simply multiply 0.5 with 14U and we get our answer as 7G, that is 7 grams. Okay, so I hope this thing is very, very clear. Okay, so we have one more sum. Actually, these sums are actually very tricky, but we are trying to understand it in very simple way. Okay, so in this particular example, what they have given is 46 grams of Na, that is sodium atoms, are given. So this is the mass given to us, and we are supposed to find out how many number of atoms are present in that. Okay, so now the first thing is we are supposed to find out what is the number of moles. In the first example, in the previous example, we saw how can we find out number of moles based on the number of atoms given to us divided by the Avogadro number. But in this condition, the mass is given to us, the given mass, and what is the atomic mass of that particular element. So atomic mass of nitrogen will come over here, sodium will come over here, and the given mass will come over here. So we are just supposed to divide both of them. So 46 divided by 23. Now what is 23? 23 is nothing but atomic mass. It's the atomic mass of sodium. So the value, the number of moles is 2. So this is the number of moles. Okay, I'm so sorry. So this is the number of moles which they have given to us. Now we are supposed to find out what is the mass. So as we know, what was the formula? The formula was very, very simple. You just simply take the number of moles and multiply it by the atomic mass. Okay. So we just actually in this condition, we are not finding out the number of, we are not finding out the mass. This is actually wrong. We are finding out the number of moles, number of atoms actually, number of atoms. Okay. So I hope you can just understand my handwriting. So how many number of atoms are exactly present in this 46 grams of sodium? Okay, so the number of atoms ka formula is number of moles multiplied by the Avogadro number. Remember, in one mole we have one Avogadro number ka atoms. That is, what is the number of Avogadro's number? 6.022 into 10 raised to 23. So in one mole we have 6.022 into 10 raised to 23 atoms. So in 2 moles, how many number of atoms will we have? We just simply multiply both of them and we get our final answer as 12.044 into 10 raised. This was about how you are supposed to find out the number of atoms present in a molecule or in a given compound if the value is or the mass is given to you. Okay, so once again I'll just repeat this whole thing, this whole numerical thing, but before that let me just say you guys that if you're just new to this channel, then please do subscribe to our channel and you can just press the bell icon so that you never miss an update from us. Also, we have our own website. We have a website that is www.letstute.com. So you can just go over there, click on the link which is in the chat box, in the live chat box, or you can just find the links in the description box. There are some amazing videos on math as well as science. You can just find some amazing videos over there. Okay, so let me just repeat the whole thing which we have gone through in the first example. So in the first example, we saw we were using law of conservation of mass. So we were just checking what is the law of conservation of mass. Is it satisfied or not? Okay. In the second condition, we were just finding out what is the mass of a particular element if a particular element ka mass is given to us. in a reaction. So if they have given that this particular thing reacts with another element and find out the mass of this particular element, we just use the law of constant proportion. The mass in which they react will always be constant. So in this also the mass will be 1:8. Okay, so in this way we just find out what is the value, and then we were just finding out how can we find out various methods. And in this particular question we were just questioned whether it will use use up all the oxygen or not, and the answer is no, it won't use up all the oxygen, because of law of constant proportion. It will only react with 8 grams of oxygen. So in this, carbon will react only with 8 grams of oxygen to form 11 grams of carbon dioxide. It won't react with any more oxygen atoms. Okay, so remaining 42 grams of oxygen are left vacui. Okay, so the next thing is about how to calculate molecular mass. So in this condition they have given us a molecule they have given us, and we are supposed to find out what is the molecular mass. So we just simply add all the atomic masses of the present in the molecule, and we get our answer for molecular mass. In this condition also we were just simply adding all the atomic masses. Okay, so in this condition, we just found out what were the values for this molecule, for this molecule, and for this molecule. The answer is present over here. We are just simply adding all the things together and trying to find the answer. And next is about how can we find the mass. So mass ka formula is nothing but number of moles multiplied by the atomic mass. So what is the atomic mass of this particular element? It's nothing but 27. So we just multiply 27 by the number of moles. So the number of moles is 4. So 4 multiplied by 27, that will give us 108 grams. So that is the mass of the aluminium, 4 moles of aluminium. Okay. Next is, what is the mass of 0.2 moles of oxygen? So the mass of 0.2 moles of oxygen is found out by simply multiplying number of moles multiplied by the atomic mass. So atomic mass of oxygen, we know what is the atomic mass of oxygen. It's 16U, and number of moles is given to us. We just substitute it in the equation and we get the whole answer as 3.2 grams. Okay, so this was about how to find out the mass of a particular element if number of moles is given to us. Okay, and in this example we found out how can we find out number of mass. How can we find out what is the mass of a particular atom if number of moles is given to us, if number of atoms is given to us. Remember, if number of atoms is given to us, you just find out the number of moles. How can you find out number of moles? You just simply divide it by the Avogadro number. What is the Avogadro number? 6.022 into 10 raised to 23 is the Avogadro number. So if you divide it by the Avogadro number, you will get the number of moles, and then you can just simply multiply the number of moles with the atomic mass of the given element. So the atomic mass of this nitrogen is 14. So we just simply multiply it by 14. So 0.5 multiplied by 14, that gives you 7 grams. Now, what happens in this condition? In this condition, you are given particular grams of sodium. So sodium grams is given to you, and you're supposed to find out what is the number of atoms. So number of atoms present in this 48 grams of sodium. So what is the formula? You're just supposed to find out what is the mole of this particular element. So if the mass is given to you, just simply divide it by the atomic mass. So if you divide it by atomic mass, the atomic mass of sodium is 23 and the mass given to us is 46. We just divide both of them together and we get number of moles as 2. So 2 is the number of moles. Now, what is the number of atoms? How can we find out what is the number of atoms? So number of moles multiplied by the Avogadro number. As we have discussed, 1 mole contains 6.022 into 10 raised to 23 number of atoms. 1 mole consists of 0.22 into 10 raised to 23 number of atoms. So how many number of atoms will 2 mole consist? We just simply multiply with that number by 6.2 into 10 raised to 23. And our final answer is 12.044 into 10 raised to 23. So this is how we are supposed to find out the number of atoms. So yeah, that's it for this session. So if you have any doubt related to the numericals, you can just type it in the chat box and we can just address that doubts. Hello guys. So guys, if you're just new to this channel, you can just subscribe to our channel. You can just find a small bell icon over there and you can just press it so that you just never miss an update from us. And also about our website, we have a website that is www.letstute.com. So you can just check it and you'll find some amazing videos on math as well as science. Okay, so you can just go and check it over there. So just type it in the chat box if you have any doubt, guys. So if there are no doubts, in 2 minutes we can just end this live session. Okay. Structure of atom. Yes, we are going to cover structure of atom. Don't worry. Vemi ready, don't worry. We will cover it. Don't worry. Just be tuned, be connected with us. Yup, ask. You can just type it in the chat box. Yeah, so for those who are new to this channel, again, I'll repeat for you guys. Just don't forget to press the subscribe button and also the bell icon. There are very useful videos which you can look at. Yeah, thank you. So make it soon. Structure of atoms. Yes, don't worry, we'll make it soon. Okay. So I guess there are no doubts related to this chapter. Okay, so that's it guys, that's it for this video. If you want more such live sessions, then please stay connected and just press the bell icon. And also we have our website. Okay, so don't forget about the website, just go and check there and there are some amazing videos. Okay, so bye guys, take care, have a nice day, bye.